Hey everybody, today we're going to be looking at quantity of heat. Heat is different from temperature. Heat is energy while temperature is vibration of molecules. Two objects can be at the same temperature but can contain very different amounts of heat. For example, consider a red hot pen versus a red hot horseshoe. Both can have the same temperature, but they contain very different quantities of heat. So it's the amount of energy that is stored in them. In this example, there are three well-insulated beakers, each containing 100 grams of water at 25 degrees Celsius. To the first is added 10 grams of water at 100 degrees. To the second is added 20 grams of water. And to the third is added 20 grams of copper. After mixing, the final temperatures are 32 degrees, 37.5 degrees, and 26.5 degrees Celsius. Looking at the results, we could see that 20 grams of water contains more heat, more energy than 10 grams of water. The amount of heat is proportional to the mass of the substance, and the amount of heat depends on the nature of the substance. As you can see, the copper changed the temperature differently compared to the water. The specific heat capacity of a substance is equal to the amount of heat required to raise the temperature of the unit mass of the substance by 1 degree. We can usually find specific heat capacities unless we want to find it experimentally inside of a table. For example, water has a specific heat capacity of 4.18. You can calculate the quantity of heat, Q, by using the mass of the substance, its specific heat capacity, and the change of temperature a substance undergoes. Here we go. So let's calculate for Q. Q, of course, being quantity of heat, is equal to mass times the specific heat capacity times the change in temperature. Change in temperature is equal to T final from T initial. Okay, let's give an example of why this is an important thing to measure. Let's calculate out the quantity of heat needed to raise the temperature of 150. So let's look at water, because we always want to boil water, right? Let's find out how much energy is going to require. Let's calculate the quantity needed to raise the temperature of 155 grams of water from 17 degrees to 35.5 degrees. So T initial, it begins at 17 degrees Celsius. T final, we want it to be 35.5 degrees Celsius. You can get the C value from this table right here. Okay. Water has a specific heat capacity of 4.18 right here. 55 grams times 4.18, and let's go ahead and joules per degrees Kelvin. Interestingly, 1 degree Kelvin, a change of 1 degree Kelvin is the same as a change of 1 degree Celsius. And then per grams. Okay, then let's do a temperature difference. So let's go 35 degrees minus 17 degrees Celsius. Change in degrees Celsius is the same as degrees Kelvin, so let's get rid of this. And when we calculate it out, we will have 1.20 times 10 to the 4 joules, which is equal to 12 kilojoules of energy. You must put 12 kilojoules of energy into 155 grams of water to make the temperature raise from 17 degrees Celsius to 35.5 degrees Celsius.